Good afternoon, everyone. My name is Sam Nasr, and this is Data Time Travel with Temporal Tables. A little bit about me. Been a software developer since 1995. Started an organization called NIS Technologies. I've been certified with a few certifications from Microsoft over the years. I also run the Cleveland C# VB.NET user group, as well as the .NET study group online. I've authored a few articles for Visual Studio Magazine, and I've been Microsoft MVP since 2013. Some general information. If you haven't figured it out by now, the restrooms are alongside this hallway. Despite the classroom-style seating, I always encourage participation. So at any point in time, jump in with any questions or comments you may have. And last but not least, if you would please mute your cell phones. So one of the things that I'm heavily involved in is the user group community in Cleveland. And how many of you attend user groups in your area regularly? Okay, those of you that do not, may I ask why?
Yeah, some of them are just scheduled at kind of odd times where I've got something else going on. But.
Okay. If you go to meetup.com, you'll find a user group in your area, more than likely. And again, more than likely will be at a non-conflicting time. There's always more than one group happening in most major cities. Those of you that attend, what advantage do you find in attending user group meetings? Networking. That's always the one that I stress the most, right? So technical content is the one most people think of, but networking is a key aspect of it. So I won't talk too much more about it, but I strongly encourage you to get out there and attend. Jumping into today's presentation on temporal tables. What temporal tables are a way to maintain a version of a specific table that you specify. So we're system versioning a table and all its records. It's based on an ISO ANSI standard. It's a new feature in SQL Server starting in 2016. And it maintains the current and past rows modified. It actually maintains two separate tables. It marries them together, and we'll see that we essentially only have to issue one query. The database engine on the back end will concatenate or union both record sets and then produce the proper record at that point in time. It's implemented via T-SQL, so we don't have to go into Configuration Manager. We don't have to install any additional modules, no additional licensing required. It works on all editions of SQL 2016 and later, including SQL Express. So as I mentioned, it is all implemented via T-SQL. And so with that in mind, with the T-SQL, here are the requirements that are needed. First of all, we need a primary key on the table. Second, we need two period columns. We need to specify the date and time. And it has to be date time 2. We can name it anything we like. And it has to be non-nullable. So for each column, it must include the phrase generated always as row start. And then the end column must include the phrase generated always as row end. And then we have a designation for the period where we specify the start and end columns that were specified in the lines 1 and 2. We specify them in the third line in the period for system clause. And then we want to mention that we want to turn system versioning on. And this is while we're creating a new table. So naturally, in the number 3 line here, we specify with system versioning equals to on. So now we're turning system versioning on and utilizing the above clauses that were implemented. The fourth line is history table equals whatever table name we decide on. So we can define the name of the historical table there. If we don't, it produces a rather odd looking name, kind of a GUID-like name, not very user-friendly, and we'll see that later on. So combining all these 4 lines together, we end up with an example as you see down here in the red square. Create table department, and now we're going to specify the primary key. In our case, we're using an identity function where we're starting at 1, incrementing by 1. We have some additional fields, department name and manager ID. Nothing extraordinary about those. But then to meet the criteria for line 2, we have to specify the valid from and the valid to. So these are basically 2 columns that specify when that specific record was alive, so to speak, when it was accurate, when it was active. And you notice, as mentioned here, generated always as row start, as mentioned here. And same thing with the valid to date. And then we take these two fields and we include them in the period for system time clause. And then we also specify system versioning on, and we specify the name of our history table that we want to marry it to. So what we're doing here essentially is we're defining a table. We're meeting the requirements of the primary key, as well as specifying a time start and a time end for the activity period of that record. And then we're including them all in clauses, and this is while we're creating a new table. So we can do this in one fell swoop by including all the clauses within that statement. So you might be thinking, well, this is great for a new table. However, what if I have existing tables, right? So this is where it would come into play. Now we would utilize the alter statement. Here, we essentially have to go about it in a two-step process. So first of all, we're going to look at our existing table. We need to add the start time and the end time for it. And we're going to do that using the alter statement. So you see, first of all, we're taking our existing table, alter table employee, and we're adding our two generated columns. And we're specifying that the default cast is going to be January 1st, 1900, which in terms of SQL is essentially the beginning of time. And then, of course, generated always for the end date is December 31st, 99. I certainly hope to live to see that date, but if I don't, it's set in there. The whole point of this is we're saying that whatever records are in the current table, in our existing table, are going to be considered active records, as they should be, right? We have an existing table. Naturally, the data that's in there is considered active. So we added these two fields. We added in our default values for both start and end. And then we indicate our period for system time utilizing the two fields that we created here. Then the second alter statement is simply to turn versioning on. And what this is doing by specifying this clause, it's essentially generating a historical table that follows the same schema as the current table. So our existing table will be essentially labeled the current table, and then when we specify the system versioning, it will create an identical table, well, almost identical, and you'll see why in a little bit, and it's going to call it employee history as the name specified here. Any questions so far? Yes, sir.
There appears to be redundancy between declaring as row start, as row end, and period for system time start and end. Is that just so that the syntax folds in with T-SQL, or are there other options that you can use with different keywords?
Where do you see the redundancy, sir?
So as row start, we're saying basically this is our start.
Right.
And then down on period for system time, we're kind of re-referencing that start date. So it seems to me to be slightly redundant that you have to declare as row start and then use this period for system time.
Aren't you creating the columns?
Exactly. So what we're doing here is we're using the alter statement. We're adding in two columns, so these could just be generic columns. The generated always just simply means that it's going to be system generated date time whenever we're populating it. This third clause is simply stating that we're going to be using it for system versioning. These two columns. I could very easily, if granted it's a bad practice, I could switch end date and start date because I can specify the column name.
Right, but we have start and end in each of those columns. So I was just curious why we then have to reference our start and end in the period for part of the column.
I wish I could answer that. I think that's a question for the Microsoft team. But essentially here, we have to specify this in the clause as the beginning and end.
Yeah, I wasn't sure whether there's more advanced options or something that maybe you could do.
There probably is, and could look into it, but typically to use an existing table and make it a version table, you would simply add those two columns there. Okay. There was another question?
Yeah, so you said that the historic table is auto-generated for you. If you're using, say, like a SQL project for version control of your schema, would that historic table also show up there and potentially could be modified and edited there?
So the question is, can the historical table be modified aside from the current table? The answer is no, and we'll see that later. In order for it to maintain system versioning, the schema has to be identical, virtually identical. And the reason I say virtually is because we can't apply the same constraints on the current table on the historical table, and we'll see why in a little bit. Okay? Yes, sir.
I think we need a primary key column in the same table, right? If we are running the auto statement.
You need a what column?
Like the primary key column.
Well, this is assuming that the employee table already has a primary key. So, besides, what are primary key used for anyways, right? They just take up space. I say that as a joke. You need a primary key. Easy. Okay. So, are we good on this? All right. Very good. So, usage scenarios. Honestly, I can't think of a good scenario where you would not use version tables. I think it's good insurance. It's going to come in handy whenever the question arises, who changed this record, at what point was it changed, what was the value before it was changed. And it saves the headache of having to go back, look at backups, doing restores, but rather everything is maintained dynamically. So these are some of the usage scenarios. It allows you to query the table going back to a specific point in time. So you could say, what did the data look like as of June 7th at 12 noon, for example. And it will give you all the records that were active at that point in time. We could also use it for slowly changing dimensions in a data warehouse. We could use it for auditing to see when the change was made as opposed to who. So if you want to implement who modified it, that would utilize CDC, or you'd have to capture the user in your record as you're making that change. And this fourth bullet, I don't know if any of us have experienced it, accidental data loss. You go to delete some records, you accidentally get your where clause a little bit mixed up, and boom, you accidentally lost some records you didn't mean to. So what do you have to do at that point? Go to the DBA, offer them to buy them lunch, right? Beg and plead. They restore the database. You get the records at that point in time, and you hope and pray that everything went well. In this case, we can just simply do a simple query, and we have the data. We can see what it was at that point in time. There's also a procedure where you can actually roll data out of the temporal table into the current table. Also, it could be used for anomaly detection. I had someone stop by at our table earlier, and he used this to actually detect that a specific application was doing 6 of the same updates in a row, and it was taking up time on the server. And when he implemented this, he could see the updates were actually being executed against that table. And we'll see how we can actually detect for that. We already talked about repairing low-level data corruption, so we can recover from that. So whenever we're querying temporal tables, because everything is done via T-SQL, we use our select clause and then specify the table name, but then we have to implement the for system time, and as of is one of the query parameters that we can use. And when I say one of, there are several that we can implement. The differences between them, I would pay very close attention to the boundaries. Is it equal to or less than the boundary, or just simply greater than the boundary? So you'll notice the difference between these 5 statements is essentially, or these 4 rather, is whether it includes or excludes that boundary. So I would pay close attention when you're executing that query to see where you need the data and at what point in time you need to bring it back. So with that said, let's dive into a demo. And the PowerPoint as well as the script are already uploaded on the SQL Saturday site. So here is my script, and what I'm going to do is, for starters, I'm going to delete the existing database and then start new. So we'll go ahead and execute the statement. And currently in use. Okay, let's do it the old-fashioned way. All right, so that's deleted. We'll go ahead and create the database. Need to restore our connection. All right, exactly. There we go. So create database. So for this scenario, I'm going to create two tables, territory managers, and then I'm going to link to territory managers from the customers table. So for starters, territory managers doesn't really have anything special regarding system versioning here. It's just a table that we're going to reference as a foreign key. We have our primary key, as we should for all tables. We'll go ahead and execute that. And now I have my customers table. And as mentioned earlier, for my customers table, I need to have the primary key. I need to have the sysstart and sysend time. Again, specifying generated always. And then in my period for system time clause, I specify those two columns. And then lastly, I specify system versioning on with the name of the historical table. So I'll go ahead and execute this clause. And we'll see that it was created. Now, if I look over in my Object Explorer, let me refresh it first. Apparently everything is running slow at this time of the day. So it'll come up, and here we go. Here's our temporal database. And if I zoom in, now we see that we have territory managers, just a standard table. But if we look at DBO customers, you'll notice that when I, first of all, looking at the icon, I see that there's a clock symbol right on that icon for that table. When I expand it, you'll see that I have the columns folder, the keys folder, and the constraints. But in addition, I also have this historical table tucked in underneath the actual current table. So when I expand this version table, and notice how it says history in parentheses, when I expand on that, I see the column structure is virtually identical, and there's that keyword again, virtually. How is it different? Because it's essentially a data warehouse of sorts, we're maintaining a constant history of our current data. This ID field cannot be a primary key like it is in my current table. Any foreign keys are also not going to be copied over. However, everything else, as far as the schema goes, has to be identical in order for me to have system versioning. Now what I need to do is to set the foreign key up against the current table, so I'll utilize an alter statement for that. Now I got my table generated, I have my foreign key relationship in place. Now I can go ahead and insert data into it. So since I'm going to be referencing the territory managers as a foreign key, I need to populate that first. So I got 3 rows inserted, and now I'm going to insert 3 customer records. When I query both tables, you'll see that I have my territory managers as expected, as well as my customers table. Now, going a step further, I know that I have a historical table, and I can query that separately from my current customers table. So querying the 2 of them, I see that my current table, it has the 3 records that I inserted, but my historical table contains 0 records. That's because these are new records, they were not updated, and so therefore there is no history to them. If I scroll over to the right and take a look at the date time columns, you'll notice that the date time set for the sys start time, it's in UTC format, but you look at the end time and essentially it's infinity, or what SQL Server would call infinity, which means these are still the active records. Okay, so it was active starting at this point in time, and it's still active till the end of time, effectively. Any questions so far? Okay. So what I'm going to do, let's say that we have a customer who's very fond of changing her email constantly, and she's always calling in and complaining to customer service. So what we're going to do is mimic that customer. And I will go ahead and update the customers table, set the email to a different address. Notice that right now, Tina is in there with the Outlook.com domain. We're going to change that to the Yahoo domain. And we're going to execute the following statement, which waits 3 seconds and then updates the email to a Hotmail domain. And then another 3 seconds and update it to a mailx.com domain. Now, Tina calls and complains that she never got a shipped email. So when we look at our customers table, if I just do a select star from customers, that brings back only the current data. So her current email is tina1@mailx.com. And again, looking over at the sys start time, I see that I have the records of when they were updated. Notice the difference in time here versus the original records that were inserted. In addition, all of them are still set to infinity, so that means they're all still active. Now, if I query the historical table, I see that I have multiple records for Tina Wilson. And notice my ID here, which is a primary key in the current table, cannot be a primary key here because I'm duplicating it multiple times. I'm maintaining a history for all those records. Scrolling over to the right, I see when those records were active. So it was active from this period to that period, and then from that period to that period. And if you look at them and you match them, essentially it's going here to here, here to here, and so forth. Okay? So as soon as one record ends being active, a new record begins and is active. And that's why we need a date time too for that level of precision, to identify exactly when that record became active or inactive. So if I want to see what was the original email that was originally entered in, I'm going to cheat a little bit and copy the UTC time where the records were inserted. And I'm going to update this field. And now when I query it, I see that at that point in time, it was Outlook.com. Now, mind you, here I queried the entire table, but I could very easily put in a where clause and specify that I want it only for that user. Likewise, if I was to alter this time a little bit, let's say we go back an hour previously. An hour previously, none of those records existed, and so therefore it brings back 0 records. So if I want to look at all the record sets, or all the collection of records for everything, here I'm specifying a time range that is far before and far after when I actually inserted those records. So here I'm going back to June 8th, 1614, which is 4:14 in UTC time, and I'm going to the future as far as 2020. When I query this, basically brings back all the records starting at that point in time up until this range specified. So I'm using the for system time and I'm specifying the clause from and giving it a time range. So naturally it brings back all the records that were active during that time frame. To help make a little bit more sense out of it, I need to look at the sys start and sys end time. So looking at it, I see that obviously these are set to infinity, so essentially they're still active. Whereas here, it shows me that these records expired at this point in time. So the advantage here is, even though there are two tables running on the back end, I have my customers and my customers' history. All I did was execute the query against the customers table. And because system versioning is turned on, it automatically queries the historical table, unions the records, and then brings everything back pertaining to that from clause. Questions? Comments?
I have one question.
Yes, sir.
Like, how long the history table will keep the record?
How long will history keep the records? Depends on what you set it to. So I have it commented out in the very beginning of the script. When I created my table, I can choose to set history retention period for 6 months, as we see here. You can also specify it in terms of days or years. But in this case, I just commented it out altogether.
Okay, so if we want to truncate the history table, is that possible without like removing the versioning?
You would have to turn versioning off momentarily, and we'll see that in an upcoming demo. Then you can truncate the table, and then you can turn versioning back on. Okay? So if you utilize this clause with a history retention, that automatically rolls records off, and so it'll maintain the history for you up until that point. If you want to go to infinity and beyond, you can just keep an eye on it. Okay, so we left off, we did the delay. We looked at the clauses.
So if you accidentally delete the customers table, does the history table go with it?
If you delete the customers table, yes.
Hey, don't laugh. Yesterday I got to work. It was supposed to be an easy 4-hour day, and then I was off in Columbus, and I found out a vendor wrote a stored procedure, and instead of dropping the temporary table, he brought the 75,000 record table, and that was my day.
Oh boy.
My easy Friday.
Yeah. But then again, it's only 75,000 records, right? Hashtag sarcasm.
He did it in another country at 4:46 a.m. I had backup at 2:25 p.m.
Okay, good. Any other questions?
Are you going to show deleting a row from the primary table?
Yes, we'll be getting to that.
What's the overall cost, or the overall overhead in terms of cost? Is it just like double store it? I mean, like these things.
I'll give you the ubiquitous consulting answer. It depends, right? Yeah. It depends on the number of columns, the type of columns. I mean, if you could imagine, if I had 20 NVAR CarMax columns here, right? Or all of them storing images or any such large fields, naturally all that effort is being duplicated. So it's double the performance hit that you have on here.
Okay, yeah, that's what I was saying.
Okay.
What happens if you already have history tables on some of your tables? Is there a method to be able to implement temporal tables and load up that history one with existing data?
Yeah, as we'll see later, there's a script where you can actually specify which tables to marry, and that will turn versioning on. But the key thing is the schema needs to be identical.
Right.
Okay? Okay, virtually identical.
Kind of takes away the need for audit fields because it's being built in.
You don't have to worry about triggers. You don't have to worry about any homemade solutions. All built in with the engine. Free of charge, comes with any version. How can you beat it? Right?
Already doing it, what's,
Right.
already doing it for something.
Exactly. So now another question is, what happens when we run these in a transaction? So looking at this, again, I'm going to pick on Tina, and what we're going to do is we're going to continue to update her email, and I'm going to start the transaction, and I'm going to note the time when the transaction started using this print statement. Then we're going to do an update. We're going to have a 1-second delay, another update, another delay, followed by a third update, and then we'll print the transaction committing at the date and time. So going forward, we'll highlight the entire transaction. And let me save this over in another file. Now when I query my table, let's just look at the customers table only. When I query my table, I see that Tina, her email address was updated multiple times. But if you notice, the start time for a transaction, 20:01 and 12 seconds. It matches the start time only of the transaction, not the end time, despite building in an explicit delay. So if we're running in a transaction, essentially the record becomes active at the beginning time period of the transaction, not the end of the transaction. Okay? Something to be aware of. Naturally, if I roll back the transaction, nothing will take place and everything will be maintained as is. Now, looking at the customers in the historical table, anytime I make a change to the customers table, it will automatically update the historical table. So we see that in the historical table, I have 6 rows. In the current table, I only have 3 rows. If I was to make an update, and granted this is not something I recommend, updating the value of the email to the current value of email, basically it's just burning CPU cycles, really not doing anything to the data. However, when I run it once, twice, 3 times, now I look at my historical table and I now have 9 rows. Basically, I updated this record for Sam Johnson. Essentially, I made the new email address equivalent to the old email address. So what I'm trying to get across here is there is no intelligence built into the record update. If it sees an update statement, it automatically writes to the historical table and maintains it. If I want to delete a customer, we'll delete the first one. Now when we select from the customers and customers historical, we'll see that the customer ID with ID of 1 no longer exists in the current table. However, when I look in my historical table, I see the last record there is for Lisa Shepard, and her record was active from this time frame to that time frame. And because she's not in the current table, therefore her record is essentially deleted for all intents and purposes. But I maintain a history of it in my historical table, and it shows the period that it was active. Yes, sir.
Yes, so if, not that people would do this in production, but identity insert on, say, ID 1, right? Would that then similarly track that you're using the same ID you would see, Bob Summers instead of Lisa going forward, that sort of thing, right?
So the question is, if I was to turn identity insert and allow identities to be inserted, will that be reflected in the historical table? Yes, it would be. The question came up earlier when I'm creating a table. Pardon me. That I can specify the name of the historical table. So there are essentially 3 different ways of creating the versioning table. So here you'll notice that I'm just relying on the default, and I'm going to create a table called Department 1. I'm specifying everything that's required. By the way, can everyone see that okay in the back? Okay. So I'm specifying everything that's required to create my historical table. I got my primary key, my sys start, sys end time, period 4 system time, and system versioning on. What I don't have specified here is the name of the historical table. So I'm going to rely on the SQL engine to generate that name. And if I go over into my Explorer, refresh the database, and then looking at the table names, we'll see that I have a table Department 1, And we'll zoom in. And there's the user-friendly name that's auto-generated for me. Okay, so that's one way of, if you don't specify the name of the historical table, it will auto-generate the name for you. You notice, again, the schema, sorry for jumping around, the schema is identical to my current table. Another option is I can just simply specify the name. And so what I'll do here, I'm going to create Department 2. Again, same structure. Here I'm specifying the name for the history table. And so it will generate the current table as well as the historical table. And
Included the schema name on this history table here. Could you have A, put it in a different schema? You have DVO dot. Could you call it history dot and put it in a history schema?
correct. Actually, that is the recommended procedures, that you put the historical table in a different schema.
What about a different database?
You cannot put it into a different database.
What about a different file group?
A different file group. If you partition it,
Not partitioned, but in the same database, different file group.
I,
Want to put it in
same
one-
database, yes, it should work.
I got one other question.
Go for it.
Earlier on, there was some syntax that was data consistency check.
Mm-hmm.
What was that?
Okay, we'll see that in an upcoming demo, as well as a slide. Essentially, when you turn system versioning on, it goes through a check, and it will give you a yay or nay, whether it passed and was able to turn versioning on or not. So we don't have full control over altering the schema between the two tables. They have to be identical.
Right. Okay. But that's just the check that says,
Yes,
yes, it is.
right. And then, last but not least, I can define the schema name for my department, for my history department, and then I can specify the indexing. Need to resize it. And then I'm specifying the name of my current table, and then marrying the two here when I specify system versioning on, so I can declare the schema for my historical table as well as my current table. And if I go and highlight all that, there we have Department 3 created with Department 3 history. And again, we'll refresh our database and go over to tables. And there's Department 3. It's thinking, and there's our historical table with the column structure and the indexes that we specified. Okay. Any questions so far?
So I have a question.
Yes.
If you run a truncate table command, so it will keep the history in the version table?
I believe with truncate, you might have to turn versioning off. I came across something about truncate earlier, so, but I'm pretty sure you can truncate it with the system versioning turned on. I'd have to double check that though.
And what about the adding a new column, like dropping a new column? So do I need to turn off the system versioning and then add a column?
You do. We're actually going to do the opposite in an upcoming demo where we're adding another alternate email address without updating our historical table. And you'll see that as we turn system versioning on, it will fail. Everyone's looking forward to a failing demo. I like that. Very good. All right. So going back to our slide deck. So some design constraints. It supports almost every column type except for file stream. Anyone here familiar with file stream? Okay. All right, so file stream, I don't want to get too far off the beaten path here, but with file stream, it's essentially a pointer to a file sitting in the file groups on the file system, but it is not inside the database. It's just simply a pointer to it. And because it is a file sitting on the file system and not in the database, naturally it can be updated without going through T-SQL. And so therefore, the file stream type is not supported. In addition, any file stream type or any data type where it can be managed outside of SQL Server would not be supported through temporal tables. The second bullet, I think this answers a lot of questions that came up. The history table cannot be modified directly. You can only add to it by updating or deleting data from the current table. So I can't add or insert any records into it. I can only modify the current table. I can't use, instead of triggers, they're not supported. And after triggers are only supported on the current table. As I mentioned previously, you cannot change the schema of a temporal table without changing the current table schema as well. And we'll see that in just a little bit.
Do you have to do each one individually then? Each table?
It's essentially an alter statement, so yes.
Each part?
Yes, ma'am. And as we mentioned and have seen, changes to records in the current table will automatically be reflected in the temporal table, and indexing must be manually enabled. Yes, sir.
What about with partition switching? Will it record the history before you do a partition switch to, like, say you have a staging table, you move all the data from the main table out and move the staging in? Will it keep that history that was in there prior?
So with partitioning, now you're talking about a very niche kind of question. Honestly, it is supported with partitioning, but as far as that order sequence that you specified, I can send you some documentation or look into it, but I don't know the answer off the top. By the way, I have some business cards here for any questions that was not able to answer. I'd be happy to follow up with you afterwards. Once we specify system versioning equals on, this is a list of all the items that take place. And basically what it's doing is, I'm not going to go through each one individually, but what it's doing is it's checking to see that the names and the number of the columns is the same for both. Obviously, for primary key, we have to forego that in the historical table. That the data types match for each column. The nullability for each column also has to be a match. And essentially, we're checking to see that the entire list of the criteria specified here is still consistent. And then, if so, then system versioning is activated at that point. So if we turn back into our demo, so here what we're going to do is we're going to purge the historical table, and we're going to remove anything with the ID of 2 from the historical table. And as we query both of them, we see that we have record with ID 2 in the current table. And looking at the historical table, we see that Tina has many records in here. So what we'll do is, currently system versioning is turned on. We're going to attempt to delete directly from the historical table, and we get an error message. So we're going to need to turn versioning off, delete from the historical table, or do a manual purge. And now, because the schema is still the same, we just modified the records. Now we can turn versioning back on, and as you see, it was done successfully. When we query the tables, I still have Tina in my current table, but I no longer see any of her old records in my historical table. Not as well. It deleted it from the history only. I'm not sure where that question came from, by the way. Yeah, I deleted it only from the historical table. Essentially, I'm purging my historical table. So as seen, I could do it manually, but I have to turn versioning off, or I can specify the retention policy on my table, and this was done in the create clause right here.
So you could have deleted the schema as a whole from the history table, or just left one record, the last record.
Absolutely.
Modify your word clause a little bit.
Sure. Right. I'm in full control. Right. Okay. Give me 1 second to search for a demo that I thought I had in here, but we'll find it shortly. I'm not sure. There we go. Okay. So now what we want to do is we're going to use the alter statement. So if I was, again, keeping in mind that system versioning is still turned on, what I'm going to do is I'm going to alter the customers table and add an alternate email field called alt email 2. When I go ahead and execute that statement, temporal DB, did I turn versioning back on? I thought I did. From customers, temporal database. There we go. So I altered apparently it was off, but in any case, I altered the current table without modifying the historical table. And so naturally, what happened there when I tried to turn versioning back on, it gave me the error message, temporal history table name is not correct for the current table, temporal table demo db.customers. So now in order to do that, what I have to do is go back and turn versioning back off again. I already added it to my customers table. Now I need to add it into my historical table. And now when I turn versioning back on, all is good. Hey, David.
Interrupt you for 30 seconds.
Sure, go ahead.
So, part of what we are doing today at SQL Saturday is we are partnering with a local charity called Grace Haven. They are a group that works with people who are coming out of situations involving human trafficking. They help victims get back on their feet, get back to normal life, get them the care that they need, get them back on their feet. To that end, we are running a silent auction downstairs, as well as in addition to a 50/50 raffle. Some examples of things that we have in the auction right now are classes from Brett Ozar, classes for SQL skills. Normally, these things are going for like $700, $800 values. Right now, they're bidding at about $125, $150. So, good opportunity to get some training and help a worthwhile charity out. We've also got autographed books from Frank Fritchie, Ben Wiseman, a couple other things as well. So, if you are interested, here's how it's going to work. This session is over at 4:30. At 4:45 on the dot, you'll send an alarm on my phone. I will be picking up the auction sheets and there will be no more bids accepted. So in 15 minutes after this class is over, if you're interested in some of those items, come downstairs, place your bid, and then at 4:45, whoever has the highest bid will win. All right? And then after that is when we will do the raffle and closing, all that.
Is that cash only?
Cash, check, credit card through PayPal or PayPal directly. We'll make the payment arrangements with you after the fact.
Okay.
So we'll get the information that we need at that time. So, thank you.
Very good. Thanks, David. Okay, we talked about the different create options. And now, going back into our slide deck. So with security, you can actually implement security by default. Because I'm DBO, I was able to access the historical table without issue. However, you can assign security access to the historical table either for read or maybe just keep them out altogether. But that historical table will continue to maintain records going forward as the current table is being updated. So change tracking versus temporal tables versus change data capture. How do all these fit into place? So as we had seen with temporal tables, basically we're able to maintain history of that current table, and we're getting all the records, and we can see when it was active and when it became inactive. With change tracking, it stores the last change made to the row, no history, only the last change. Change data capture, or CDC, it records the DML activity of the changes in the table, but doesn't really give you history. So each one has its own place and a fit. Best practices when designing your temporal tables. For converting an existing table, consider using the hidden clause to hide the new period columns. The reason for that is many developers use the select star from when they're querying the table, and so naturally now they're going to be getting additional fields back into their query that they may not have code to support. So by making those fields hidden, then it will prevent that issue from happening. As mentioned earlier, pay close attention to the boundaries whenever we're using the clauses that were mentioned earlier for querying. And again, here's a quick revisit with the subclauses. So we need to pay close attention to which one we're using. You have the from, between, and contained in. And essentially with that, you got to pay attention to the boundaries less than or equal to, greater than or greater than and equal to. That can be a trip up when executing T-SQL. Well, not executing it, but the results you get back could trip you up, I should say. Last but not least, it's best to utilize a separate schema for maintaining history, so that way it's isolated from the current table. Any questions? David?
Entity framework.
Yes.
Does that tie into this?
So with entity framework, the clauses, I believe, are not supported. However, as you know, EF Core is constantly evolving, and so is EF for EF Core. I'm sorry, EF for .NET Core. Currently, it's not supported, but in future versions, it probably will be. As far as the querying, but all you need to do, if you keep in mind that you're updating a table, the history is automatically generated for you on the back end. So you don't have to do anything special there.
But it's kind of like a SQL first approach. You can't really do code first and set this up.
I don't believe it's supported in EF. Not yet. Okay. Other questions? Yes, sir.
For transactional replication, if you add the base table, will it push it over to subscribers as a system version table or history table as well?
So replication is allowed and is available for temporal tables, but there are some caveats to that. And again, I can send you the link with the documentation depending on your specific scenario. But generally speaking, yeah, it is supported. Other questions? Yes, sir.
I have one question.
Sure.
Okay, so for the base table, so let's say someone has a select permission on the base table. So if we create a version table, so he will automatically get access to the version table, or we need to maintain it separate?
If you maintain it in the same schema, then yes, they will have access to it. However, you put it in a separate schema, you can deny them access or not give them access at all to begin with. Okay? Yes, ma'am.
Is there a way to, say, store the last 5 updates made, like that person keeps changing the email address, you don't want that in there 20 times. Is there a way to like say, she's got 5 in there now, delete the oldest one, or something like that?
As far as number of records, not by retention policy, but there are also other ways of maintaining retention. I don't believe any of them would fit that scenario that you mentioned. But in all honesty, if you had someone that was modifying it like that, I think it would be best to keep those records because it would show an anomaly of some type that's happening. Okay? Other questions?
If the history table's in a separate schema, if you're looking at the base table, is it obvious that it has a history table in here?
Yeah, so what happens is when you marry it using the system versioning table, system versioning equals on, you're pointing to the schema.table name for that history table. And so again, the database engine connects the two, and whenever you're querying the current table, it'll also union the records that fit that criteria from the historical table, regardless of the schema that it's in.
And you can tell where it is by looking at properties?
You can specify the schema name in there, yes.
No, but if you don't know where it is,
If you don't know where it is,
you're looking at the properties, is it gonna, or dependencies?
yes, it will tell you where it's at. It'll be stated there.
Can you like right mouse click and script to query window your primary table? Does it then show the history as part of it?
Yes, and let's take the customers table, and, oh, wrong one. So tables, let's minimize that. So it's expanding, and it's going to show the historical table. So this is for the historical table. Now if we script this, and we go to script table as, create to, query window, there's our historical table.
Now that you've expanded it, can you script current?
So I tried on the actual current table, and as you see, it is not an option for me.
That's kind of weird. But here at the history table level, it doesn't really say that there's a relationship with that to the primary.
Here, no, but if we
Is there a custom report for that?
if we go to properties,
The system views will have all of it.
Yeah, well, it's there. I don't want to right mouse click on your table.
Well, it nested under it.
Let me go use PowerShell. Sorry, this is early.
so it'll, yeah, it doesn't specify it.
Well, how lame is that?
Okay. Because of the time constraint, just wanted to mention a few resources. There's a lot of documentation out there regarding temporal tables. Depending on your scenario, I suggest, again, there were some questions regarding partitioning and file groups and replication. So the majority of, as I answered, I gave a general blanket answer. However, if you look up at the documentation, it could be the opposite for your specific scenario. There's a lot of if, ands, or buts. So I invite you to visit these links for the exact scenario you're looking at. Unfortunately, within an hour, we could not cover all the scenarios, but there's some great resources there. Also, if you're interested in your organization or yourself taking on a course in temporal tables, I'd be happy to help you. Visit us at nistechnologies.com for a list of courses that are available. A lot of SQL Server related development topics that are not easily found. And lastly, my contact information, Nasr at NIS Technologies. You can also find me on Twitter, and I invite you to connect with me on LinkedIn. So I won't keep you past 4:30. However, if you'd like to stick around afterwards and ask questions, I'm very open to that. And with that, thank you all for attending.